All right, good morning, everybody. A couple of days later, and I am answering the other questions. So these are two questions I've added. Um, they're actually, this is what you would see for merit and excellence, and we'll explain a bit more. This bottom question, you will always get this. This is called relative risk. Let me just highlight that relative risk. Underline, bold, relative risk. This was in the PowerPoint that I sent to you. If you've read it, hopefully you're good with it. It is an excellence question, as I said, so you need to be really, really slick with how you approach this. Okay, so read it over again if you're not quite sure of what to do. So, but first, this kind of is a question that leads into it. You can see how it's related. This is called conditional probability. Let's just write that over here. Conditional probability. Okay, so conditional probability, if you've read this with the PowerPoint slides and made some notes, this is not talking about the total population. So our total population is at 250. Conditional probability is about a smaller population within that. So what is the smaller population? It is waiting Blue's Clues effort. Yeah, it is those who received medicine. So that's what our total population is. Our total population is not 250, but it's this 188. So we know that it's out of 188. No, hold on. Oh, I totally stuffed this up. It's not out of 188. Nice. It's of those who receive medicine. Okay? So of those who receive medicine is 150. Guys, I'm not going to cut this video. I'm just going to keep rolling with it. Actually, so that shows what like a typical mistake you can make is looking at the column instead of the row. So you're given medicine. The amount of people who have taken their medicine, received medicine, is 150. Now, of those who received medicine, what was the probability that the headache went away? Again, same strategy. We look over. Now we're just looking at this row. We're not looking at all of it. We're just looking at this row. Okay, so it's out of 150. The headache went away. 132. And if you like Rion and you want to put into percentages, by all means, you can do that now. Let me find out where my calculator is. 132 divided by 150. Okay, there's one away. 132 divided by 150. Okay, 88%. 88%. Okay, alright, so hopefully you can see that. Obviously, there's a lot more people whose headache went away taking the medication than people whose headache didn't go away. So that we can always compare that. Yep, that looks about right. Now, relative risk. We're going to break this down into smaller steps. First of all, whenever you see relative risk, let's not worry about the relative part. We'll get to that. But we're just going to look at the risk. So we just want to calculate the two conditional probabilities. So let's write this down in steps. Ooh, let's make it none and red. Okay, so the first step is finding out just the risk, which is the conditional probability for both groups. What are the two groups that we're going to be talking about? Okay, so we see these of those, for those. That means it's conditional probability because we're conditioning the population. It is not the whole population. It's conditional. It's conditional on the fact that whether they took the medication or not. Okay, so what is the relative risk of retaining a headache for those who took medication and those who had the placebo? So luckily, we know over here, these are the people who took the medication and the headache went away. So let's just do a bit of just grouping, making sense of it. So headache for those who took medication, we know is going to be 18 out of 150. And I'm just guessing, Maggie, but it's probably about 12%. Okay, so hopefully you can see that. Now we're also going to look at a headache for those who took placebo. So again, it's the same thing. We're going to look, it's just those who took the placebo, so it's out of 100, and it lingered over there, so it's 44 out of 100, makes it really easy, 44%. Now, what do we do with these? It could be really easy to just compare the 18 and the 44 and say, yep, the people who took placebo look like it's twice as likely to get a headache, or the headache still remains. But we see this is 44 out of 100, and then we see that this is 18 out of 150. So actually we're dealing with different amounts. We want to put it on an even keel, and when we did this 18 out of 150, it's actually 12%. So we're pretty much comparing 44% with 12%. And the best way to do this, relative, means we're dividing / we're trying to figure out a ratio. So to do that, we're going to do 44 divided by 12. We're comparing how much bigger 44 is from 12. Putting that in the calculator, should be able to do it. Okay, so we get 3.6667. It's reoccurring. So what does this mean? In the last bit, you need to put this in words again. So this means that the probability, the relative risk, let's go relative risk of those who take a placebo versus those who take medicine, probability of, relative risk of retaining a headache for those who take the placebo versus is, let's say 3.5. You can say 3.6, but we're doing words, is approximately 3.5 times more likely. Okay? So going over this part again, this is the merit and excellence part. There are other questions that they can ask, but we really require our understanding of normal distribution that we'll be going on to pretty soon. So, you see over here, we have conditional probability, so that's when we're looking at just a smaller population or a subpopulation. So we see those who receive medicine is 150, and then relative risk is just finding out the percentage for each, the two subpopulations, and then comparing them. Now, our term relative, when we see relative, we can talk about dividing or a ratio. So we figure out that it's going to be comparing a percentage of one percentage versus the other. Now, actually, I could have done this. I could have, because we get 44% by going 44 divided by 100, and then I can actually go insert symbol. Where's the symbol? Let's just go equation. It's easy to find. I could have done 44 divided by 100, and that's all divided by 18 out of 150. Now, I know we're talking about ratios, so if we did the opposite, if we went like this, 12 divided by 44, we would have got a answer that is, we call that the inverse. So this is 0.272. If you get this, it's a bit harder. What does this mean by words? This means those who took the medication are 0.27 times more, exactly. So we're saying 0.2. That means it's less than. If you're stuck, if you find relative risk that is less than 0, that's not good terminology, right? We're not going to say that, oh, I'm 0.27 more likely. That doesn't make sense for our language. So if you see something like this and it is below 1, just invert it. Okay, so below 1, so we equal, so it's the same as saying the other population, 44 over 12. All right, my recording limit is at an end, so we'll see you later. We'll see you later. Where is it? Oh my goodness, I can't finish this.